Okay, today we are continuing on with more properties of different stuff inside of circles. That's what all week long is going to be. Yesterday we spent some time looking at some basic properties around tangents. We saw it wasn't very difficult stuff, not a whole lot of properties, just some basic math problems going on inside of our circles. Today we're going to see a little bit more of the same, a couple of very simple properties. It's not going to be very difficult to understand. It's just understanding what you're seeing in the picture and then applying the properties to the picture. Okay, so let's follow along. Okay. Here's the first property. And this thing, I've got it massively color coordinated. And you're going to see that a little bit on a lot of the rules that we talk about with our circles because a lot of it is a lot of words referring to a lot of stuff in a diagram. Okay, so the rule is going to say that if a diameter of a circle is perpendicular to a chord, then the diameter is going to bisect the chord and its arc. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, now obviously we need a diagram to go along with this conditional statement. And I broke it into two diagrams because there is a lot of stuff going on in this statement. Okay, the circle on the left, okay, that is the hypothesis part of the statement. If you have a diameter and it is perpendicular to a chord, that's what's being shown in the circle on the right. I'm sorry, the circle on the left. When this happens, this rule states that the diameter is going to not only bisect the chord, but also the chord's arc. Now that's a little bit something different that we haven't talked much about. We haven't talked about a chord having an arc, okay? But obviously a chord, okay, and you remember your definition of a chord, it's just a line segment that has its endpoints on the circle, okay? It has an arc that's caught between the two endpoints, and here it is down here at the bottom of this right-hand circle, okay? And the rule says that that arc will be bisected as well, and that's why we have the little sets of tick marks. Okay, another property or another situation, I guess, that could arise. Also dealing with chords, let's say we have a chord that is a perpendicular bisector of another chord. If we have a chord that is a perpendicular bisector of another chord, then the first chord is going to be a diameter. This statement is basically the reverse of the statement that was made at the top of the screen. Okay, the first statement was stating that you did have a diameter that was perpendicular and it caused a bunch of bisecting. Now we're saying that we have a chord that is a perpendicular bisector, so it is now establishing that when that happens, you get the diameter back. So it's kind of like the same property being applied from two different standpoints. Okay, and again, I broke it into two different diagrams because of just so much, there's so much stuff inside of the picture already. Okay, so the hypothesis part of the statement over here on the left, if you have a chord that is a perpendicular bisector of another chord. So you can see that we have the right angle, that gets our perpendicular part of it. There's the bisector part of it because of the tick marks that are shown. Then the conclusion is, well, what's so different about this diagram over here on the right? Mark the center point in it. Okay, that chord that was coming north-south inside of that circle, it passes through the center of the circle, making it a diameter. All right, if I remember correctly, this is the last little tidbit that we're going to look at today dealing with chords and arcs. And this one states that two chords are going to be congruent if they are equidistant from the center of the circle. Sure. Okay, so a diagram of this situation would look something like that. And again, I've broken it into hypothesis and conclusion. If two chords are congruent, if they are equidistant from the center. So the hypothesis is if two chords are equidistant from the center. So that's what we're seeing in this picture on the left. We've got these two blue chords, the black dotted lines or dashed lines reaching out to the chords. That is the measurement from the center. And then you got the little tick marks in there showing that that measurement is the same in both cases. And the property establishes that when this happens, the chords have no choice but to be the same lengths. Okay, well, that's all of the information. The rest of this is just learning to identify it when you see it in a picture. The problem with circles is there's so much different stuff that can happen, so much clutter that can show up in the circle, and they're not going to come out and tell you, oh, by the way, we're using this particular rule in this problem, so answer the question. They're just going to throw a circle up there with whatever they choose to throw in it. It's going to be up to us to correctly identify what's in the picture and then figure out how we can use what's in the picture to figure out whatever they are missing. Okay, well, as you've been looking at this picture, copying it down, we've got three different variables in there. Okay, we've got A, we've got B, we've got C, and we're going to solve for all of them. Okay, well, you don't have to solve for them in any particular order or anything like that. Let's just think about them alphabetically here for no particular reason. Okay, it's just a way to go through it. What do you think about A? Okay, you think A is 2? Okay. Now, why should we think A is 2? Okay, it's a good suspicion to have that A is 2, okay, because it looks like the circle is, symmetrical on either side of this diameter that's coming through it, okay, and it should be symmetrical, okay. But do we have a property that backs that up? Okay. We have a diameter that comes through our circle, okay, and it is perpendicular to a chord. Okay, well, one of our properties just said, what happens when a diameter is perpendicular to a chord? One of the things it said is that the chord is going to be bisected. Okay, so if it's 2 units on one side of the intersection there, then what's it going to have to be on the other? It's also going to have to be 2. Because if a diameter is perpendicular to a chord, then the diameter bisects the chord. Okay, so there's that. How about B? What do you think about B? Okay, 65 degrees. We think it's 65. Is that a good thing to think? Yeah, same property. If the diameter comes through, okay, and it's perpendicular to a chord, it wasn't just the chord that was bisected, it was also the chord's arc that was bisected. So if one side of that bisection is 65, then the other one doesn't have any choice but to also be bisected. So 65 degrees on B as well. Okay. All right, how about on C? What do we think about C? 25? Okay. Any other thoughts? Okay, the only vote we got is 25. How'd you come up with that? That is very close to being right. Okay, the answer that we got, for those of you that are listening out there on Edmodo, okay, we got that you take 65. Um, Say it again, Daniel. I forgot already. Okay, yeah, 65 two times, and then subtract it from 180, and then divide it by 2. There's only one little thing that Daniel missed there. Can anybody help him out? Hmm. Yeah. Okay. What Daniel was saying is he wanted to would take 65 and another 65, and then take that away from 180. Okay. And then divide the remainder of that by 2, and that would tell us what was going on. Yeah, there's what we need right there. How much does the circle measure? Yeah, 360. So you got great strategy. We just had a bad number plugged in there. Okay. Yeah. Now a different thing. the way we could have thought about it is where Daniel may have confused himself. Okay, this line coming across here, is this a diameter? Yeah. How much does that measure? That's 180, right? So could we take 180 degrees on the semicircle, take the 65 degrees away from it that we do know right there, and just see what's left over for C? Okay, we could do that. And either way, we would come up with a good answer. Okay, and we're going to find out that it is, what is it, 115 degrees are going to be left over for C. Whether you tried to treat it as the entire circle, where C and this arc over here were going to be congruent, okay, that's fine. You'd have gotten the answer. The top way would have been a little bit more work, but you certainly could have done it that way as well. Okay, so good thoughts there. Anybody have any questions on these three? Okay, let's take a look at another one. I only put together these two examples because it's not really a whole lot of rocket science going on. It's just identifying what you are seeing in the problem. Okay, so I'll give you a second to copy this one down, and then we'll talk about it. Okay, in this particular circle's case, we've got two variables, x and y this time. Okay, doesn't matter what order you get them in. Let's just see what we can figure out. Does anybody have any thoughts on x? None? Okay, chords are congruent. Okay, well, if that's the case, can we just go ahead and establish what y is? Yeah, how do we know that the chords are going to be congruent? Okay. Well, we have a rule that says if two chords are equidistant from the center of a circle, which is what we have, then the chords themselves are going to be congruent to each other. One of them measures 7, that means the other one measures 7 as well. Okay, so that one's kind of easy based upon the rule. Okay. Now what about x? Coming back to x. We said that the chords are congruent. Okay. Do you think that that has any bearing on the arcs that are outside of them? Yeah, it does. We saw it in a small piece in this rule back here. What happened when this chord was bisected? We ended up with two pieces of two chords that were bisected as well. Okay, that relationship holds true right here. If these two chords are the same lengths, then these arcs that are caught outside of them don't have any choice but to be the same length either. Okay, now great. How does that help us out for the problem? Oh, yeah, yeah, yeah. So if the chord, there you go. If the chords are the same, then we've got 190, and we've got an x, and then we got another x. Okay, yep, and we know that they all add up to be 360 degrees. So from here on out, all we have to do is clean up the problem. An x plus another x is two x's. Let's get the constants away from our x's, subtract them to the other side. And then divide by 2. Okay, so there is x. X equals 85 degrees. Okay. Okay. Guys, that's about all that there is. Okay, the rules themselves, the properties are not all that complicated. It's just spotting them when they happen to show up in the problems. Okay, so there's an assignment that goes with this, so let's get to it.